Hello. All right, we're going to go through a little bit about time value of money, and this is a very important concept, probably one of the most important concepts you'll learn in school because it can change your life dramatically. Once you understand this concept, you then have to have the discipline to implement these strategies into your life consistently. All right, so when people kind of ask. They ask what's the difference between saving and investing. So saving is for shorter term goals, usually under 4 years. Examples would be saving money for a vacation or having money in an emergency fund. A savings account gives you cash right away, so it is considered liquid. So what you want to do is with your liquid money, you want to put it into an account that is FDIC insured. So that stands for the Federal Deposit Insurance Corporation. And they insure each person's money to at least $250,000 currently, up to each account. And so, if you have a checking account, it's insured up to 250,000. If you have a savings account at the bank, that's insured up to another 250,000. So it's by account type at each bank you're located at. And then you can earn interest on your money when you put it into generally a regular savings account without any online direct deposits or anything. You're going to generally get a pretty low rate. But if you go onto online bank accounts and you have direct deposit, you generally could get a higher interest rate. So that's something to consider if you do have a job and you do have direct deposit. But if we don't need the money within 4 or 5 years, we want to consider investing our money. So these are for longer term goals. And so in this unit we talked a little bit about the stock market, the S&P 500. It's a combination of 500 companies that make up the stock market. The 30-year return in most windows of 30 years is usually around 10% annually if you reinvest your dividends that you receive. So it's important to reinvest those dividends. When you invest money, your money is generally not as liquid as it is in a savings account. So I could go to the bank today and get my money. Now, in the stock market, they now have a 24-hour window where they'll get your money to you in 24 hours, which is a big improvement because it used to be 5 days and then went down to 4 or 3. And more recently, now I think they have it down to almost a day now. So stocks a little more liquid than they used to be. But investing gives you the ability to increase your net worth. So if you take everything that you own, your bank accounts, the stuff that you have in your room, and you deduct anything that you owe, that's your net worth. So most high school students have a positive net worth. That means they have more assets and liabilities. But many students then go off to college and start borrowing money, and so their net worth turns negative for a while. But eventually, if they get a better paying job and they get a degree in a better paying job, or they get a certificate to be an electrician or something like that, they'll once you kind of start earning money, you could turn that net worth positive again. But to really grow it to a large amount, you have to understand the concept of interest. So interest is when someone gives you money for your use of your money. So when you borrow money from the bank, they're going to charge you interest. If you make an investment, they'll charge. You'll receive interest. So there's two types of interest. There's simple interest and compound interest. Simple interest is you have, let's say you have $100,000, you put in the bank at 10% interest. The calculation is principal times rate times time. So that's how we calculate interest. So the principal is the amount that you deposited. The rate is the annual percentage rate. So by law, banks have to tell you what the APR is if you're depositing money or if you're borrowing money. So for car loans, for mortgages, for credit cards, they have to tell you what the annual percentage rate is. And then the T in the formula is for time. So the default is 1 because this is based off of 1 year. It doesn't compound generally greater than 1 year. So if it compounds annually, the T would be 1. If it compounds monthly, the T becomes 1/12 because there's 12 months in a year. If it's quarterly, there's 4 quarters in a year, so it'd be 1/4. If it's semi-annually, which is twice per year, it'd be 1/2. But the default is 1. So we're just to kind of get you going here. There's the $100,000, 10% compounding annually. You get the 1, so there's the 10,000. So when we add up the 5 years of simple interest, we get 50,000. Now, compound interest is taking the interest and wrapping it back into the principal and then doing the calculation again. So compounding interest at the end of the 5 years gives you $11,051 difference. So I don't know about you, $11,051 is pretty good in 5 years. But really, the moral of the story here is that 11,051 is the compounded interest. But if we do this over long periods of time, and if you kind of look down on your worksheet, you can kind of see I kind of stopped it, at the end of 5 years there. If we really push this out and go further, we're going to get to the ending number after 40 years of doing this. We're going to end up with $500,000, $500,000 on the simple interest side. On the compounding interest side, you get to $4.5 million. So the calculator is the tool that kind of allows us to do that. So if you just go into Google right now, so if you go into Google and you just type in financial calculator, it'll pop up the different financial calculators. I just picked on this one. I like this one. It's pretty simple. It's clean. The TBM calculator. You also have this on your calculator, but if you just want to follow along on here and then you can use this for the assignment, that'd be great. All right, so we're investing $100,000 today. So here I have the variables, the same variables over here, and the PPY and the CPY. This is payments per year, compounds per year. That's this right here. So that's the saying, how often is it compounding? So in the first one that we did, I'm just going to walk you through how we got the numbers. We're compounding annually. The 10,000, the 100,000 is what I'm putting in initially into the investment, and I'm not making any payments. It's a lump sum. It's a one-time amount, and the annual rate was 10%. So I know in math you normally type in 0.10. In the financial calculator, it will move the decimal places for you. You just put it in as a whole number. I know it's kind of weird, but just put it in as 10. And then the periods, we're letting this go for 40 years. So when we do this, we get a future value of, you just click on the FV here, there's the 4.5 million. So if we go over here, there's the 4.5 million. So there's a penny rounding difference there. But there we go. There we have our number, okay? Now, what happens if we change the problem that we want to compound it monthly for 40 years? So I want you to kind of think about this for a second. There's 12 months in a year, and if we compounded monthly for 40 years, we got to change this to monthly. First things first, we're going to get this to monthly. Now, the number of compounds, remember, how many times is it going to do principal times rate times time? Is 40 times 12. So that's how we get the 480. So once we type in that 480, we're ready to solve for our future value. We get 5.3 million. So look at the difference. If we compounded monthly versus annually, we're going to get an additional, whatever that comes out to, 800,000 roughly, more dollars. So that is worth noting. We want something that compounds more frequently. Now, it says, what happens if we use our original problem, but instead we put 110 as the beginning investment? So we're going to go back and change this to 110. We're going to set this back to monthly or annual again. So 40 annual. Okay, let's see what our answer is. Our answer is 4.9 million. So we went from 4.5 million to 4.9 million just by putting an additional 10,000 in. So the amount of money that we invest is important. What happens if we use the original problem, but instead we half the interest rate? We go to 5% interest rate instead of 10. We're going to get 700. Let's see here. I got to put the 100 in again here. 100. The original problem, remember, 100 was our original number, so we get 703. So there's the 703. Look at that difference, a 10% return versus a 5% return. The millennials in 2008, they saw the stock market go down 40%. It took about 3 years the stock market got to back where it was at. But it really freaked out millennials. They didn't really like the stock market, and they kind of stayed away. They're good savers in comparison to other groups, but look at what they're doing here. They're getting a lower interest rate off of savings, and over a long period of time, you want to be involved in that, in something that gets a higher rate of return over a longer period. That's why you have to be in better types of investments than just letting it sit and getting a lower interest rate. Because that's a big difference in your life's net worth, $703,000 versus $4.5 million. And you might say, well, Mr. Nurbekas, stock market's in the short term, the stock market will fluctuate. Look, in 2020, it went down 40%. It took a month to get back to where it was at. It went down, it went back up. That was like a month or two recovery. 2008, it took a few years. early.com, it took 4 years, and that's why that rule of law of if you need the money in 5 years, do not mess around the stock market, because there could be short-term fluctuations, but the overall trend of the stock market is up in the long run. And you might say, well, there's nothing to predict that in the future. Well, if the stock market were to go down permanently, everyone's financially is in trouble. So it's kind of a weird point to go off of. So we're going to assume that inflation is going to continue to occur, stock prices will go up, and you want your money to grow higher than inflation, and the stock market kind of does that. All right, so conclusion on the simple interest formula. Interest equals principal times rate times time. Each variable is important to the total interest earned. The more money you put in, the better. The higher rate you have, the better. The more frequently you compound, the better. Keep this concept in mind as we move forward. So I'm going to end the future value of $1, and I'm going to pick up on the future value of annuity problem.